So this question here looks at calculating the area between two given curves. Now when you see something like that, whether it's the diagram, the question, etc., what I instantly want you to do is remember that to calculate the area between two curves, we have to use integration. Now when it comes to this, there's a couple of key things we need to know. We need to know the function we're going to integrate. We need to know the limits that we're going to integrate between. Now, we're quite lucky in this question. It gives us the 2 points that we're going to integrate between because it's the points of intersection of the two curves. So we're given those in the form of the -2 and the 1 there. If it didn't give us those, we'd have to calculate them. And we'd do that by setting the two functions equal to each other and solving it and seeing what solutions we can get and making sure we pick the appropriate ones here. If we were to do that for this one, we'd find a third point of intersection, but we're not actually interested in the area up to that point and including it. So we'd have to disregard it. That would be the first thing we'd have to do. The second thing we'd have to do is get the expression for what we're integrating, then integrate it, substitute in the limits, and get ourselves a solution. Well, one thing I need you to make sure that you remember is that for the integral between any two limits, a and b, of any function, what we have to make sure we do is that we take the top curve and we subtract the bottom curve from it. And we integrate with respect to the variable they're in, and in this case that's dx. So if I do in this case top curve minus the bottom curve, remember it's top curve of the area, so it's this one take away that one, what we'd end up getting is the x cubed minus 2x squared minus 4x plus 1 take away the x minus 5. Point to note here is in this part I've got the cubic being the top one. If I were to integrate in this section above here, now obviously I'm not in this question, but if I were, note that the top curve, the top equation would be the x minus 5. So it would be x minus 5 take away the cubic for that section there. Now we're not bothered or interested in that at this point in time. That could come up in another question or another scenario. So simplify this here. I've got x cubed minus 2x squared minus 4x plus 1. Take away the x minus 5. That'll give me x cubed minus 2x squared minus 5x plus 6. That is the function I'm now going to integrate. So what I'm now going to calculate is the area by doing the integral between my two limits, which in this case are the points of intersection, -2 to 1, of that function x cubed minus 2x squared minus 5x plus 6 dx, because I've got to say what I'm integrating with respect to. So what I'm going to do is use my usual integration technique, go term by term and integrate them all one by one. Now remember to integrate, raise the power by 1, we then divide by the new power that we have. So here I'm going to get x to the power of 4 divided by 4, take away 2x cubed divided by 3, minus 5x squared divided by 2, plus 6x between my two limits of 1 and -2. Continuing on, what we then do is we substitute the top limit, take away the substitution with the bottom limit, and we get an overall answer there. So what we'll end up getting is 1 to the power of 4 over 4, take away 2 times 1 cubed over 3, minus 5 times 1 squared over 2, plus 6 times 1, take away -2 to the power of 4 over 4, minus 2 times 2 cubed, -2 cubed, over 3, take away 5 times -2 squared, over 2, plus 6 times -2. So what we now do is we take that, work it all out, get a full final answer together. We can use our calculator for this because remember this one's in a calculator paper. What we'll eventually end up getting is we'll get 63 over 4, which is also the equivalent of 15 3/4 square units. We're not told the units that we're measuring in. Let's just include square units though to show we know what we're going on about. So that question there covers calculating the area between these two curves. Now it seems like a lot of work, but again, it's a set of steps that hold firm that we can really keep in our mind as a general set of steps that we follow when we get this type of question. Firstly, remembering we do top curve, take away the bottom curve. Then we need to know the limits we're integrating between, so the points of intersection. We integrate every single term then one by one using our standard technique. Substitute the upper and the lower limits in, and then do a final calculation of subtraction and getting our final solution for this. So this question here, worth 5 marks. First mark is for remembering to do upper, take away the lower. Second mark is for stating the full integral out. Now, the first 2 marks are available if you were to state everything in an integral. So if I stated the integral from 1 to negative 2 of x cubed minus 2x squared minus 4x plus 1, take away the x minus 5 dx, I'd actually get those first 2 marks because I've shown the 2 scales in one go. And if I went along and integrated it every single term one by one, at that point without simplifying, yeah, I'd give myself some more work, but I'd still be following the right technique, so I'd still get subsequent marks. Next mark would be for integrating correctly. The fourth mark, substituting in upper and lower limits and knowing to subtract them. Final mark for your final answer. It doesn't ask for it in a set form, so you could have it 63 over 4 or 15 3/4 units squared. Doesn't matter, whichever one you want. Don't have to play about going between them. So there you go. Like I say, seems like a lot of work, seems like a lot of maths and a lot of complex analysis in there. However, what you've got to remember is the big skills that higher brings into this one is knowing how to integrate and knowing how to use your limits. Things like working with subtracting 2 functions from each other, that's something we should be able to do. Simplifying algebra, something we should be able to do. Substituting in values, again, skills from previous years, we should know what to do. We can recall all of these skills and all of this knowledge. If we can work with all of these skills and all these knowledge and apply them to this higher level of material, along with these new skills that we've learned and new techniques that we're working with, what we'll do is we'll actually find that we get this fairly straightforwardly, and it'll be relatively easy once we get to it. So remember, that's what we're ultimately trying to do. Make our lives easier, and if we can do all that, bring in all these skills, this year becomes easy peasy, lemon squeezy.